Hey guys, it's been a while, but we're finally back, and in today's video I'm going to be showing you how to set up a first-person controller. So without further ado, let's jump right into this video. Now real quick, before we actually get started, make sure you hit that subscribe button as it helps the channel out and is completely free. And I'd like to also thank you guys so much because we actually recently hit 1,000 subscribers and I couldn't have done that without you. So thank you guys so much for the support. Also, I actually made my Discord server public, so you can actually join the Discord server if you want. The link will be in the description. Now just be warned, my Discord server used to be just a weeb anime Discord server, so there's some interesting people on there and some interesting conversations, so just be warned. Anyway, we're gonna start by adding a kinematic body, and we renamed that to player, and as a child of the player we're gonna add a mesh instance. Then with the mesh instance selected, we're going to the inspector, clicking on mesh, empty, new capsule mesh, clicking on the mesh once more, and then we're going to give it a radius of 0.5 and a mid height of 2 should be good. So let me see, yeah, we're going to actually give it a mid height of 2, and then we're going to rotate it along the x-axis by 90 degrees, and we're going to move it up so that it's flush with the floor, and that actually looks good to me. Now with the player selected, I'm going to go ahead and add a collision shape. And then over the inspector, I'm going to click on shape, empty, and then add a new capsule shape. And we're going to give it the same parameters as our mesh instance. So in this case, it's going to have a radius of 0.5 and a height of 2. Then we're just going to rotate it along the x-axis as well and move it up so that it actually covers the mesh instance. And that looks good to me. Then with the player selected, I'm going to go ahead and add a spatial node. You could also use a position 3D node, but I'm just going to use a spatial node, and I'm going to rename this to head. Then with the head selected, I'm going to go ahead and add my camera so that we can actually see our level. And basically we want to select our head and move it up so that it would basically be in the location of where the head of our player would be. Then we can actually select the camera and preview it to see what the view would look like. So that would be how our view would look like for our player. Now we can actually save our player scene here. I'm just saving it in a folder called player, and we can actually add our script now. So I'm just adding it as an empty script and I'm just calling it player. So go ahead and actually create it. Now in the actual script, this is actually going to be pretty similar to my third-person controller video, and the link to that video will be up above on the screen if you want to watch it. Anyway, we're going to start off by defining all the variables we need. So in this case, expert var max speed is equal to 12, expert var acceleration is equal to 60, expert var friction is equal to 50, expert var air friction is equal to 10, I think should be a good value for this. And yeah, we're using 2 friction values because we're going to have different frictions for the ground and when we're in the air. Anyway, we want to add an expert var for the jump input so that we can actually jump, and then expert var gravity is going to be set to -40. And then we also want to define some expert vars for our sensitivity. So expert var mouse sensitivity is going to be equal to a default value of 0.1, and then expert var controller sensitivity is going to have a default value of 3. And we're using expert var so that we can easily adjust them in the inspector. Anyway, we're gonna define another variable. In this case, it's gonna be var velocity is equal to vector 3.0, and then var snap vector is also gonna equal vector 3.0. And we're actually gonna be making use of the snap vector so that we can add slope support later. But for now, we're just gonna continue and do an unready var for the head, which is equal to $head to select the head of our player. And then we want to do function ready, and inside the ready function we simply want to do input.set mouse mode to input.mouse mode captured, and this line of code basically sets our mouse to be captured by default when we launch the game. And that's pretty much all that line of code does. Now we actually want to add another function. In this case, it's going to be a function onHandled input, and then it's going to have the event. So this is actually a default function for Godot. Anyway, inside that function, we just want to do if event.isActionPressed and then an action. And I actually already set this up. So you want to go into your settings, input map, and as you can see, I already set up all the different actions I need for things such as toggle mouse mode, move forward, click, move right, move back, move left, jump, look right, look left, look down, and look up. I already defined all the keys, as you can see as well. And I also added the controls for the controller as well. And if you don't know how to add an action, you just simply write the name up above, and then you press the plus sign, and then you assign a key or button to it as you wish. Anyway, since I already did that, I'm just gonna click and, well, I'm gonna define the click action inside the event.isActionPress, and inside the if statement, I wanna do input.set mouse mode, and I wanna set it to the input.mouse mode captured. So when we click on the screen, our mouse is going to be captured. Essentially, that's what this line of code is doing. Anyway, we want to add another if statement. So in this case, it's going to be if event.isActionPressed, and in this case, it's going to be toggle mouse mode. So we're going to use this if statement so that we can actually toggle between captured mode and visible mode for our mouse. To do this, we're going to add another if statement. So if input.getMouseMode is equal to input.mouse mode captured, meaning that our current mouse mode is set to be captured, then we want to actually do input.setMouseMode to the input.mouseMode visible when we press the toggle mouse mode action key. Else, we want to have it be input.setMouseMode to input.mouseMode captured. So I just duplicated the line above and moved it into the else statement so that we can actually get that behavior. Anyway, if we actually test this out, as you can see, we can actually toggle between captured and visible mode, and if we click on the screen, it will also capture our mouse. So with that done, let's actually add our movement for our player. So to do this, we're going to add a function of physics process delta, and inside this function we want to start off by defining a variable for our input vector. So var input vector is equal to get input vector, which is a function we're going to define right now. So function get underscore input underscore vector, and all we're going to do inside this function is we're going to do var input vector is by default going to have a value of vector3.0. Then we're going to do input underscore vector dot x is equal to input dot get action strength, and then in this case it's going to be the move right minus the input dot get action strength move left. And then we're just gonna simply duplicate this line of code here, and instead of dot x, we're gonna change it to dot z, and instead of move right, we're gonna change it to move back, and instead of move left, we're gonna change it to move forward. And basically, we're doing get action strength because it returns the value between 0 and 1, and we can use this essentially so that we can by default support joypad as well as our keyboard. Anyway, after having done that, we're simply going to return the input underscore vector dot normalized if the input vector dot length is greater than 1. Else, we're just going to return the normal input vector value. And the reason we're doing this is so that we can actually better support our controller essentially, because there's some issues with controller if you don't do this. Anyway, these two lines of code here, the logic behind that depends on the orientation of our player. So since our player is facing the negative z direction, that defines the logic we're doing here. So if we actually want the player to face the positive z direction, then we would do the opposite here. We would do the move left minus the move right, the move forward minus the move back. So it just depends on the orientation of your player for the logic that you need for that those lines of code. Anyway, let's actually apply our movement. So for this, we're going to add another function. So it's going to be func apply movement. And inside this function, we actually want to pass a couple parameters. So in this case, it's going to take in the input vector, and it's going to take in a direction, and it's going to take the delta value. Then we want to do an if statement. So if direction is not equal to vector3.0, meaning that we're actually moving, then we want to do velocity.x is equal to velocity.move toward. So we're going to use the move toward so we can actually support acceleration. So it's going to take in direction times max speed, comma, acceleration times delta. And then we're going to do .x at the end. And move toward basically just moves this vector towards a value. So we define what we want to move towards. And then the second parameter is what rate we're moving towards it. So that's what we essentially define there. Anyway, we're duplicating that line of code, and instead of .x, we're changing it to .z. And that actually is going to work, but I don't think we actually need the input vector, we just need the direction. So let's actually get our direction so that we can actually use the apply movement function. So we're gonna go to the physics process and do var direction is equal to get direction, and that's gonna be a function we're gonna make, but we're gonna make sure that we actually pass the input vector to this function. So func get underscore direction, and make sure that we actually do var direction is equal to vector 3.0 by default inside the function, and then we want to do direction is equal to the input vector dot x times the transform dot basis dot x, and then plus parentheses input vector dot z times the transform basis dot z. And then we simply want to return the direction so that we can actually use it. And the reason we're getting an error up here is because we're forgetting to actually pass the input vector to the function. So that should get rid of the error. So the line of code here basically is making use of the transform.basis, which basically gets the local coordinate system. So it's making use of transform, which is what we actually want to use in this case. And then we're just returning it. Anyway, we want to make sure that we actually now call our apply movement function in the physics process function. So apply movement, and we're passing the direction and the delta value to it. And then to actually move, we want to do velocity is equal to move and slide for now, and then we're going to pass the velocity, and then we need an up direction, and our up direction in this case is going to be vector 3.up. So if we actually test this out, you will see that we can't actually see anything, or we can't tell if we're moving because there's no level. So I actually went ahead and I have a test level that I've been using for other tutorials as well, and we're gonna actually use this same test level for this tutorial as well. So we're gonna simply go ahead and add our player to this test level so that we can actually tell if we're moving or not. So that looks good to me. So now I should actually be able to run this and test it out and tell if I'm moving. And as you can see, we are actually properly moving, and it seems to be working. Now we can't actually move around, and there's a couple issues, like we can't seem to stop yet, and there seems to be some issues with collision, but let's actually address some of those issues right now. So let's address the issue of not being able to rotate. So to fix this issue, we're going to go into the unhandled input function, and then we're just going to simply do if event is input event mouse motion, and input dot get mouse mode is equal to input dot mouse mode captured. If all of this is true, then we want to go ahead and actually do rotate underscore x, and if you control click on it, it basically rotates the local transform around the x-axis by an angle in radians. And actually this should actually be rotate underscore y. And then we're gonna use dig to rad so that we can actually use degrees instead of radians. And then inside the parentheses, we're gonna do minus event.relative.x times the mouse sensitivity. Then we're duplicating that line of code with Control D, and we're just gonna add head.rotate underscore x this time, and instead of the .x for the relative, it's going to be .y. So the first line of code is going to get our horizontal movement, and the second line of code is getting our vertical movement. And as you can see, it's already working when we actually test our game out. Now, like I said, there's some issues with the collision. I'm not quite sure why that's an issue. We're gonna have to check that out. And there's also the issue where we can't actually stop our player from moving. So let's actually try and fix those issues now. So let's actually first start by fixing the issue of not being able to stop. So we're gonna actually make a function to apply our friction. So func apply underscore friction, and it's going to take in our direction and delta value, and then we're going to do an if statement. So if direction is equal to vector 3.0, meaning that we're actually no longer moving, then we want to do if is on floor. So we're checking if we're on the floor. Velocity is going to equal velocity dot move toward vector 3.0. So we want to make sure that we actually head towards 0 so that our player actually stops at a rate of friction times delta. Else, we're going to do velocity is equal, or actually we want to make sure that we do velocity.x in this case, is equal to the velocity.move toward direction, and it should be times the max underscore speed, and then it's gonna be heading towards that at the rate of air friction times delta. And then we're just duplicating that line of code, and instead of the .x it's gonna be .z, and we want to make sure that we actually don't forget to put .z and .x at the line at those lines corresponding to said lines. And if we test it out, it actually doesn't seem to be working. So let me actually check my code here, and it seems fine. So let me actually write the function to apply our gravity. Maybe it's because we're not on the floor and we're floating. So let's do func apply underscore gravity, and it's going to take in the delta value. And then inside the function, we're going to do velocity.y plus equals the gravity times our delta value. Then we're going to do velocity.y is equal to clamp, and then the value we're clamping, so the velocity.y, and then the min value that it can be. So in this case, the min value is going to be the normal gravity value, and then the max value it can be is going to be the jump impulse. And if I test it out, and it still doesn't seem to be working. So let me actually check if there's any issues with my collision. So let me check the collision layers for my level. Okay. And let me check the collision layers for my player here. So let me see, and I think that might actually be the issue here. So let me go to project settings and scroll down and find 3D physics and actually define the layers here. So layer 1 is going to be the player layer, layer 2 is going to be the enemy if we had any enemies, and then layer 3 is going to be the world layer. So for the player, we're going to make sure that it's actually on the player layer. And then for the mask, it's actually masking for the enemy and the world and the player. And then for the actual level, we want to make sure that our platforms are set to the collision layer of world, and so for the same for the walls. Now, I don't think we need an actual collision mask for either of them though. So with that, if we actually test the level out, and it still doesn't, well, it's the collisions seem to be fixed now, so that's good, but our gravity isn't working and we still can't stop. So let me check the code once more, and that looks fine. And actually I just realized I forgot to actually call them in the physics process, so that's such a beginner mistake. But make sure you actually call the functions in the physics process so that they actually work. So call the apply gravity and pass the delta, and then the apply friction and pass the direction and delta to it. And now if we test it, it all should actually work, and it does seem to actually be working. Oh man, well, there we go. We have collisions, we have friction and gravity, and if you just want a basic first-person controller, then this is all you need. But I'm actually going to add more functionality, so I'm actually going to add a variable jump. So to do this, I'm just going to add another function. So in this case, it's going to be func jump, and then inside that function, we're going to do if input.is action just pressed jump and is on floor. Then we want to do velocity.y is equal to my jump impulse. And then we want to do if input.is action just released jump, and we're doing this line of code here so that we can actually get the variable jump. And we want to make sure that we actually do and velocity.y is greater than the jump impulse divided by 2. If this is the case, then we want to set the velocity.y equal to the jump impulse divided by 2. Now you could set it to a different value if you want, but I just felt that that was the best value in this case for this game. And make sure you actually call it in the physics process. And as you can see, we actually have a variable jump now that is actually in fact working. So look at that, we have a jump for our first-person controller now. Now there's some weird clipping issues with the camera, so let's actually fix that now. So select the camera, go over to the inspector, and then for the far, we're going to change this to 200. And then if we test this out once more, we no longer have that clipping issue, so that's good. So we're going to go back to the player script, and let me actually run it once more. before I actually go back to the script. And as you see right now, as the first person controller currently is, we actually slide down slopes. So we're actually going to make use of our snap vector now to actually add slope support. So to start off, we're actually going to add a new function to update that snap vector to what we need it to be. So func update snap underscore vector. And inside this function, we're going to do snap underscore vector is equal to minus get floor underscore normal if is on floor, else we want it to be vector 3 dot down. So we're doing get floor normal here because it returns the surface normal of the floor at the last collision point, and we're doing minus so we actually get the right floor normal we need. Anyway, inside the jump function, we also want to do snap underscore vector is equal to vector 3.0, and we're doing this because without that line of code there, we wouldn't actually be able to jump, because by default, and we're actually going to change the move and slide to be move and slide with snap, and by default this function actually basically disables our jump, so we need to make sure that we actually disable the snap vector so that we can actually jump. Anyway, it takes a bunch of more parameters, as you can see here. So you can look up the documentation to see all the parameters and read up on it if you want, but we're going to actually define those values now. So the second value in this case needs to be the snap vector. So the first value is fine. The second value needs to be the snap vector. The third values are up direction. Then we're setting to the stop on slope to true, because by default it's set to false. So then we're going to keep the default value of max slides to 4, that's fine. And we're also going to keep the default max angle, which is 0.7853. I believe that's the right value, and it should be 398 at the end as well. And as you can see, it's actually working already, so we aren't sliding down these slopes anymore. So look at that, we have slope support for our game now. Now we're actually going to do one more thing, and that is we're going to add full controller support. So to do this, we're just going to do func apply underscore controller and then underscore rotation, and then we're going to do var axis vector is what I'm going to call it, and we just need a vector 2.0. In this case, vector 2 is going to be fine. We don't need a vector 3 for this. We just need 2 directions, so a vector 2 should be fine. Anyway, we're going to do axis vector dot x is equal to the input dot get action strength look right minus the input dot get action strength look left. Then we're just duplicating that line of code and changing the dot x to dot y in this case, and then the look right to look down and the look left to look up. And then we want to do, let's see, we just want to do an if statement. So we're going to do if input event joypad motion this time. So if this is the case, then we're going to do rotate underscore y dig to red minus axis vector dot x times my controller sensitivity. And then we're just duplicating that line of code, and we're just gonna add head dot rotate underscore x, and then for the axis vector it's gonna be dot y instead. And then make sure that you're actually calling this function in the physics process, and that should actually do it for our controller support, or joypad, whatever you want to call it. And let's actually test it out. So and actually there's this issue here where we can actually rotate along the y-axis all 360 degrees, so let's actually fix that. But let me actually check out the controller support, and it is in fact actually working, so that's good to see. So let's actually fix the issue with our vertical rotation. So to fix that, we just simply need one line of code, and we're actually gonna add that line of code after my apply controller rotation function that we're calling in the physics process, and all we're adding is going to be head.rotation.x is equal to clamp, and we're going to clamp the head.rotation.x, and we're going to clamp it to a min value of dig to red minus 75 degrees, and then dig to red 75 degrees. So we're basically clamping the max vertical rotation that we can do to negative 75 degrees and positive 75 degrees. And we're gonna actually do one more thing, and that's gonna be to actually add rigid body interactivity, because right now, as you can see, we can't actually stand on these boxes. And the reason we can't do that is because by default, we actually have infinite inertia, which can cause some of these issues as you see here. So let's actually add rigid body interactivity. So if we actually control click on our move and slide with snap vector, you will see that by default we have infinite inertia set to true. So we're just gonna set this to false in the move and slide with snap. So now if we actually test the code, you will see that we can't actually push the boxes anymore, as you can see. And we're going to actually have to apply manually and impose force to the rigid bodies to actually get them to move. So to do this, we're just going to go ahead and do this in the physics process instead of add another function. And all we're going to do is for IDX, so index for index, and we're just going to make use of the get slide count function. So for index in get slide count, and inside that for loop, we're gonna do var collision is equal to get slide collision, and it's gonna be given the index. And then we're gonna do if collision dot collider, and the collider is just the thing we're colliding with, as you can see, dot, and it should actually be is underscore, and we're gonna actually make use of a group here. So I actually already beforehand added all the boxes to a group called bodies. So we want to do if collision.collider is in group bodies, and you want to actually do this on your end also. So add every rigid body that you actually want to interact with to a group called bodies to actually make this work. And we're going to be making use of the apply central impulse function, which applies a directional impulse without affecting direction. And actually you could also probably use the apply impulse normal function as well, but we're going to use apply central impulse instead. Anyway, back to the code. We want to do inside the if statement, we want to do collision.collider.apply underscore central underscore impulse, and we're going to pass the collision, well, minus collision.normal times the velocity.length times push, which is a variable we haven't defined yet. So let's actually go up to the top of our script and define that variable. In this case, it's going to be an export var, and actually I'm going to set it in a way that it actually has a min and max value. So it's going to be export parentheses int, and it's going to have a min value of 0 and a max value of 10, and then var push by default is going to be set to 1. So with that, we should be good to go. Let me just check the code here, and actually I don't know why I used direction times max speed here for the friction. Just set that to be vector 3.0 instead. Now if we actually run everything, everything does appear to be working. Our friction still works. We can actually push the boxes around, as you can see. We have variable jumps, we can jump, move, and everything seems to work. So with that, you're actually done, so congratulations. So I'm going to be leaving a link to the GitHub project in the description. Oh, and some of you actually might know that I'm thinking about releasing a Kickstarter project for an online multiplayer course for Godot. So if that's something you're interested in, then I'll leave a link to the Kickstarter page in the description, and feel free to share with friends and family, as I would help the project succeed. Also, I haven't forgotten about it, so I'll probably release more details about it in the following week. Anyway, as always, if you liked the video, make sure you leave a like and consider subscribing, and I'll see you guys in the next one.